Just it wasn't a question, but just a comment about the accumulators. Um, although it was correctly mentioned that transformation accumulators will get counted multiple times, and actions are supposedly only counted once, but you cannot actually count on that. So accumulators are, you can treat them as a good estimation, but not as 100% number. There's a situation where, in case your executor dies, even for actions, your accumulators will double count. So that's just something to note. Um, in case you want to use it, it's more of like a order of magnitude or estimated or close to the truth number. Can't be 100%.
Okay. Yes. Yes. Thank you. That's the case. So at any point, please feel free to interrupt and clarify if I might have said something that is either confusing or you think that that is not the proper way to explain it. Please jump in. So anyway, today's lab was related to doing operations with RDDs, so somewhat similar to what we did in the introduction. So what I have right now on the screen is the programming guide on the Apache Spark website. And to get there, you go to spark.apache.org, and then you go to programming guide. And there are several ones: the quick start, Spark programming guide, data frames, and there's another one on MLlib, GraphX, and SparkX. So today, because we'll be working with RDDs and somewhat we already seen this, just a reminder that RDDs are lazy, and what that means is that in a way transformations are not actually executed or are not applied into the RDD until you perform an action. So there are different types of transformations. We saw some of them, and to have completed the lab, you would have to go over each one of them. So we had map, filter, flat map that was used. The other ones I don't think they were related they were not required for the lab. Group by keys, certainly reduced by key. And then all the other actions somewhat that we already seen. We have reduce, collect, count, first, take sample that is required for the lab. So that is just a reminder and sort of a reference point. Every time you want to have some sample code or you want to have a little bit more of documentation, you can refer to the programming guide, or if you want even more granular, you can go to the API, which you find also on the spark.apache.org webpage, and then going to API. And then if you're programming Scala, you would do it at Scala. Otherwise, you would do Python. And then there's a search box in case you want to, let's say, RDDs. That's what we're going to be looking at today. PySpark RDD. All right. So the lab today was related to word count. So I do have the solution here, but let me actually try to see if we can code it as we go. So community. So at this point, you would have already imported the notebook. So if I go here and go to week 2, lab 1, and and import the code. The very first part is it's actually Python code mainly. There isn't much of Spark. Oh, actually, no. The second line, it is already some Spark because you're parallelizing a list. So if I run this particular cell because my cluster is not available anymore, I could just relaunch it. So you don't always have to go to the cluster and start it, but you could just, by running one cell, sort of save one operation by starting the cluster and then attaching the notebook to the cluster itself. So the very first one, we have a list of words, and then we will parallelize those words. And then if we want to see what the type of that object is, well, it's a PySpark RDD. The next, and then where you can start seeing what the dynamic or what's expected in for the lab is on the first exercise where you want to get the plural. Of course, you know, this won't necessarily apply to all. There would be exceptions where the plural is not simply adding s to the end of the word, but just for practical purposes, let's just pretend that that is the case. So the very first thing that you do if you enter what this make plural function is expecting is a word, and we simply add to the word, which would be a string, the character s. So in this case, the solution will be pretty simple. You would add the s string. So that would convert the word cat into cats, which is the exact same thing that is in this other cell. There is the test library, which if in case that it wasn't working for you, there are instructions here, so I'll let you do it on your own. But for what I've seen so far in the submissions, people were successful at running this test library. So in this case, well, what you're doing is just simply comparing that the first element of this function is equal to the second element of the function, and then the error message will be the third element of that function. So in this case, we pass the string rat, and it would convert it to rats. Next would be to apply that to the full RDD. So we already have an RDD, and it was that list that we parallelized in the first cell. And we would have to fill in the code. What sort of code would go there would be if, remember that map would expect a function. So you could pass a function. In this case, we will pass a lambda function. So the function that you would like to pass, given that we already have defined the function make plural, will be something like of this sort: lambda x of make plural of x. And what this is saying is, for each one of the rows of this RDD, take the value of that row and apply the function make plural. And remember that this is a transformation. So therefore, the result of this operation will be a new RDD. And this new RDD, remember, would not be actually processed until you perform an action. And in this case, if we want to see the result, we are calling collect. Remember that collect would bring the full RDD into memory. So that might not be advisable when you have a large RDD because you might run into out-of-memory problems. Instead, what you can do is do things like take, and then you would pass an argument. So you would take a number of rows, or you would take an order version of the RDD, and that would be more advisable if all you're doing is exploring. So in this case, because it's just a small data set, that is okay doing. And the RDD had 5 elements, and now we get those same 5 elements, but the plural version of them. Next one, we'll run the test on that, and hopefully this test will pass. So all good at T there. Now the next operation is oh, wait a minute, is this the same? Oh, and C, make plural. Oh yes. So I don't have the I don't. So actually, so there is a message here on the chat for Zoom, and actually this solution is um, for the next for the next bullet. So here we're passing a function. Remember, if we go back here to what the RDD to the API, and it will look at map. Oops, map. And probably this is alphabetically, so we can scroll down to map. So map would expect a function. So in this case, because we already define make plural, we can just directly pass that function. So what that means is, maybe this is a little bit bigger. What that means is that I can just pass the function make plural to map, and then in fact that works. Then for 1D, this time is asking you to use a lambda function instead, and that is exactly what we had in the previous one, or that I had typed in there. So you can do this version where you pass the lambda function. In this case, because it's a very simple function, you could actually explicitly type the full function here. So you would do x plus s. So if we were to comment this out, it would give the exact same result. But of course, when you have more complex functions, you would ideally define this function somewhere outside and then pass that to map. Then the next what is the difference between the two approaches? They are the same. They will effectively give you the same. If you can ask the question with your voice, maybe that is better, because sometimes I might miss what is written on the chat, and then also more importantly, other people can hear the question. So there was a question in the chat, and the question is, what is the difference between the two approaches? So the approaches where we use the lambda function and the other function, they're just syntaxing, different syntax, but the execution will be the same, and especially in this case that we have a very simple function.
Armando, just one point is that in the case of the lambda where you call a functions, for each element you're going to call two functions, where the lambda function and the plural, and when you implement it in the lambda, it's just calling one function. So it would be less computation calls.
That's a good point. Yeah. Yeah, that's a good point, because lambda, it is a function. You're absolutely right. A lambda is an anonymous function. Yes. All right. In this case, the rows are I would say very simple objects, because each one of them is a row. But in the case that you have some sort of a structure within the row, you might want to define the function outside and then do that sort of operations in there. At least from the readability point of view, that would help as well. And that is, for instance, you can have a row that have hundreds of elements on it. So each one would correspond to one column. All right. So now we go into the next, which is finding the length of each word. So in this case, we use map, m lit lambda function to return the number of characters for each word. So remember that this plural RDD that we saw here, yeah, plural RDD would contain, it will be an RDD of strings, and in this case, or row, or the rows would be the strings. And in this case, what we want to do is do another map function. And remember that each one of the elements will be a string. So therefore, we can apply directly a Python function, in this case, length, which is len, of x. Any questions until here, or maybe people that use different approaches to go about this particular solving this particular item?
Hi, I have a question.
Yes.
Yeah, so this is unrelated to this particular thing, but so the test library we are using, is it open source? How is it like?
Good question. I'm not sure. Let me get back to you after, given that it's off topic. But yeah, I'm not sure. If somebody has the answer, please say now. Otherwise, I'll get back to it after to you.
Okay.
All right. Good. So we could run the test, and oops, and this should work. This should pass the test. All right. Very often you have your RDD is made out of tuples. And how do you go about those tuples? In this case, there is we want to convert that RDD into a key value pair, where the key would be the word and the value, would be the whatever you, sorry, I got confused a second. I just got a
So in this pair, Armando, you're
yes.
supposed to put the word and the number 1. So
Yes.
in the future, you'll sum it up.
Yes, exactly. That is the goal of this exercise. Okay. So the next one is sorry, getting back here. So exactly, what is the motivation of creating this key value pair is to then group all those keys together, and then group all the values together. In this case, if you group all the values together, it would give you the count for each one of the keys, in this case, the words. So how do we go about it? In this case, would be very straightforward. We do map of x, and then we would bring x and the number 1. So that is good. And then next we count. We want to count those RDDs. So, or sorry, we want to count those key value objects. And why is that? Well, in this case, we are interested in counting the frequencies associated with each one of the words. So one approach is to use group by key. We saw some of this in the previous session, and we talked about where and we reasoned that group by key might not be the right approach, especially if you have a large data set, because it involves a lot of shuffling. And what that means is that when you're doing group by key, you would transfer all the keys for one, all the keys to one partition, or you would group all the keys into one worker, and that can come from multiple partitions. So you will do a lot of shuffling. At some point, you are going to have to do that shuffling, but you can, in a way, start working intermediate steps or do intermediate aggregates that would reduce the amount of data that you move to each one of the workers or among workers. So in this case, we want to do simply group by key, and so that was straightforward. And what it's doing is, of course, taking the key, in this case, each one of the strings, and then the value associated with it would be the list or the set of values associated with each key. And remember that we constructed this in a way that we set the value to 1 for each one of the keys. So therefore, if the key rat, in this case the first string, is present 2 times, it means that the set associated, or the value associated with this group by, will be those 2 appearances. If instead you had 2, it would be 2. And this, if the value associated with rat would be 2, then you would have 2 lists, or you would have the element 2, or depending how you constructed your data set. The next idea would be, if you are interested in counting each one of the elements in this particular list, that would, in principle, would tell you what is the size, or how many, or what is the frequency associated with each one of the values. You could do it in many ways. One way would be to count the size, or get the size of this particular list. Another way would be to sum the values. And then, in principle, just because the way we built the data set, or we built this RDD, the results should be identical. So let's try those approaches. So for instance, you could do, one good thing to do is, especially because you're working in this notebook environment, sometimes if you forget what the content of your data set is, you can always remember. You could do something like take, and then let's say in this case take 2. Right, because the result, remember that the result of each one of this is a group by. That's why in this case we're properly unpacking it, and that's why we're able to print it nicely here. So in this case, it might not be so useful, but nevertheless, it gives you an idea of what is the structure of your data. This happens often when you're doing many transformations. You might, especially, and then if you're running them, maybe you forgot the order of the cells or how you run it. Sometimes it's useful to examine the data that you're working with. So going back here, remember that in this case we want to count the number of elements in each one of those groups. So therefore, we create a lambda function, and we are saying that the first element of the lambda function would be the key, and the value would be the length of the second element. So, oops,
you forgot the map.
Forget the map. Yes, thank you. All right. So, but as I said, that is not the only way. You could actually try to sum all the values inside the list, or you could do something like this. If you notice, before we're doing just the value x. In this case, x would represent the row. So we're saying take the first element of the row and then the length of the second element of the row. Alternatively, you could say instead of lambda of x, you can say lambda of a tuple. In this case, the tuple, the first so this is Python. You're unpacking the whatever is entering the lambda function, and you're unpacking it into two values, the key and the value. So in a way, these two approaches are equivalent to each other, but somewhat the second one might be more readable. And I can't remember exactly what happened, but in Python 3, I think the first approach might not work. I'll get back to that with a special note on Python 3 because things change in Python 3. So this particular approach might not work. All right. Any questions until here? No questions. All right. So I was saying before that one alternative of counting the number of elements would be to, in this case, sum the values associated with each one of the keys. And the reason for that is the construction that we did. We said a value of 1 for each time the key is present, and you can think of it as making a histogram. That is the exact same approach that you do. Every time you get a data point and it falls within the bins that you're interested, you would add one little unit to that bin size. So equivalent, very similar to what happens when you do histograms. So how do we go about it? So in this case, we're reducing by key. Sorry, 1 second. Notice that in this case, we're doing reduce by key. Before we had group by key. And what that means is that we are doing some aggregations before we reduce all the keys. So let's say that you have many partitions, and in the first partition you have I think we can go back to would be useful to look at the diagram that we saw in the last session. Okay. Okay. So in this case, when we do group by, or when we do reduce by key, we do intermediate aggregations. That in a way, what it does is reducing the amount of data that is shuffled. If you use the first approach, when we had group by key, first you have to group all the keys into or pass them to one worker, and this in a way would do a lot of data shuffling. Imagine that in this case we only had 2 keys. If you have multiple keys and of course a larger data set, then that could be very costly. So in principle, if we could do some pre-aggregations before we do the data shuffling, we are saving we're saving the amount of data that we transfer. And that is what we're doing here. We're reducing by key, and what we're saying is to add the values. So so then we should get exactly the same result. In fact, we do. Then the expert version of the code performs the map or the RDD, reduced by key, and they collect in one statement. Any questions until here? All right. Lambda. So the first thing we do is we map x to x and 1. So we're mapping or with the purpose of then reducing by key, and then adding. Oh, add is not defined. It was because I didn't use this operator. So you could do it like this, or you could do it in the exact same way that I did before, where you had where you pass a lambda function, or you would define the add function, which what it does is just takes two elements and then add them one to the other. So in a way here, we are doing all the operations in one. And I guess the purpose of this is to show that you can chain different operation one after the other, so but only all those operations will be executed when you call an action. Any questions? I'll take here.
Hello. I have a question in general about those pair RDDs. So suppose that I have an RDD which I want to use several times in order to perform different queries, and I want it to be performant. Is there some reliable extension which provides me with like bit trees for the key?
What do you mean? What?
So, for example, if I had a database and I had a big table, I would have a major key, and I'm wondering if there is something similar for RDDs.
There might be, but I'm not sure if somebody wants to answer that. But one thing you can do is cache that RDD into memory. That would certainly would help with the performance. But in terms of the libraries, I'm not sure. If somebody has an answer, please unmute and share with others.
On the same topic, if I use instead of an RDD, one of the SQL versions of RDD, is this possible there?
Yes. Well, we will get to data frames next week, and then we will explain those sort of SQL statements.
Okay, so those things exist there. So I mean, I'm just asking so that then there is no reason to search for that. Okay.
Yeah, but you know, somebody can expand if they feel now.
Okay, thank you.
Okay.
Yeah. So the thing about RDDs, you may get that, but the better options is to use the data frame, because it will also propagate down that operation. So if you have like a data frame that's based on a database, it will pass that group by command to the database, and it will down in the database before it comes back to the RDD. So in general, if you're looking for performance, data frame is the better solution.
Yes, absolutely. There's certain optimizations that are performed on top of, or they're performed for data frames that are not available for RDDs. Thank you. All right. The next is to find unique words and a mean value. So we already have the words RDD, which is sort of like our toy example, but at some point we'll get to something more interesting where we actually read a full text and then do operations on it. So in this case, if we want to count, if we want to, count how many, calculate the number of unique words. Now this is making me think. So we have, yes, so we have word counts, which we have here, right? And in this case, the keys are unique. And why the keys are unique? Because we already perform a reduce operation on it. So we want to count the number of unique words. We will simply count the number of elements in this particular RDD. So in this case, we don't have to remove duplicates because the keys are, again, unique. If you don't have a guarantee that the keys are unique, you would first have to remove duplicates, and there are the duplications available here. There you go. There are ways of deduplicating duplicates. Anyway, maybe I just confusing people, but the idea is that because you already have unique keys, you don't have to remove duplicates. So all you have to do is just count the number of elements on that word counts RDD that we have defined previously. And in this case, they should be equals to 3. That's correct. Oh, the answer was here already. All right. Next is to find the mean number of words per unique word in the word counts. And then the instructions are to use the reduce action to sum the counts and then divide by the number of unique words. So this is a two-step process, and there is somewhat outlined here. So the first thing that you have to map is what do you guys think would be? So if I pass the lambda function, anybody wants to share their solution or? All right. Then I will, we'll continue. And exactly, you would have you're only interested in the value because that is actually the number of times or the frequency of each one of the words. And then the reduced portion would be simply to add those add each one of those values, right? That will give you the total count. That will be the total number of words. And then if we want to take the average, therefore would be taking that total count divided by the initial by the word counts RDD by the number of elements in that RDD. All right. Any questions until here? Sounds good. But we've been doing all this in just a toy example. Let's try now to apply the same sort of function to a file. So in this case, if we this particular function word count creates a pair of RDD with word counts from an RDD of words. So what this function would do will return some operations that we would apply to this word list RDD. And the first thing we do is to map this function or to map yeah, this is the exact same thing you guys have done before. So add, map each word to the number 1 and reduce by key, and then so we'll pass the operator add. So that is good. And why did we go to the trouble of creating this function is because at some point we will pass an RDD, and then also, I guess, showing a different way of doing the same sort of operation that we did before. I'm going to skip over the regular expression just for the interest of time, unless somebody has a particular question related to regular expression. Maybe we see it in the context of the usage. All right, no questions. Sounds good. So we are in 4B. Okay. So the question, the function that we are interested in creating is a function that takes the text and removes the punctuation. So we could define a variable called no punctuation, and then we'll pass a regular expression. In this case, we are we could we can remove the words that are so this is another approach, but let me actually show this approach first, which is more straightforward. So in this case, what we're saying is that the characters that we want are only the characters that belong to the set A to Z and 0 to 9. One thing I notice here is that we first would have to transform to lowercase. Lowercase will be equal to text, and then you would call lower, which is a string method. And then finally would remove from the no punctuation, we'll remove the leading and trailing spaces, and then that will be what we return. Let's see if this works. Oh, lowercase is not defined. Oh, I see. There's a typo here. All right. Okay. Any questions related to this? I think there was at some point people were having some issues with the regular expression. Another way of doing it is if you import the string library, and then there is an object called string.punctuation. So that would be an alternative way. I will put this in the solution, but that will be an alternative way of removing the punctuation. So in this case, lowercase. Sorry, I think there was a question. Yes.
Yeah, Armando, would you be sharing your solution later with us?
Yes. So what would happen after is that I will share the solution and then the assignment of the 2 homeworks that you are supposed to grade. So we will do that in one email. All right.
Hear me?
Yes.
Can you, if you change \s to space, actually I will get some different results. You go down to the next function.
Sorry, in here?
Yeah.
Let's see if I get that. So you're saying to do this. You're saying to do this?
Yeah, to space. Add a space there.
I have, oh, here?
No. Just change the \s to a space. Yeah.
Okay. And what are you saying is that you get a different result where?
You go down next block. You go down. We were doing a test for the
Oh, I see what you're saying. When you run on the full text.
Yeah. The Shakespeare one things you go to the whole test. The test result will be different from the solution you provide.
Oh, yes.
Yeah, just to clarify, a /s is not space; it's any white space. So if you have tabs or anything like that,
yes,
it will be also included. So that could be why you get a different result.
that is in fact the reason.
But yes, but the requirement is like you want to keep only the letters and the numbers and the space. You remove everything else out. So suppose they should get same result, right?
Yeah, you would get the same result if you don't have those special spaces. So yes, let me see something here.
Actually,
I think what might be happening is in that Shakespeare text, there are actually other characters as well. So using a space is not going to remove them.
That is correct. So I'm here. A white space special character will match any of the specific white space above. So exactly. So that means that it's not only the space, but it's also the tab and the new line and the return. Like it was what he mentioned. So I think that's why it's giving you different count.
I mean that actually the final result will only keep the space and the letter and the words. So the final result should be the same. I mean, but actually it's a little bit different.
Yes. So you can take a look of. I mean, we can check the documentation, but yeah, this is the definition of the character /s, as it was already mentioned. All right, let's go on. So we're here, and the next we will load a text. In this case, is a data set that is already somewhere us, and these are the complete works of Shakespeare. So you could just read it here. You don't have to import it, or you don't have to put that data set into Databricks. One thing is, let's say that you're interested in analyzing some data that is not available in the data sets available to Databricks. So one thing you could do is sort of like the hack version that or adding the stub words. So one of the things in there is we're copying it directly to the driver. That is definitely not do that. But instead, what you would do is you would mount a S3 bucket into your community Databricks, or if you're running somewhere that is not Databricks, you can directly give the path of the file, whether it's HDFS or if it's the local file system, then you would pass that. And then I think there was nothing expected to be done here, but the only thing is just showing or adding this line number, and then just showing an example of the text that we're looking at. All right, so at this point, it becomes, in the initial part, somewhat repetitive of what you had done before, so counting words, etc. The first section asks you to do words from lines. So what that means is that the first issue is that we need to split each line by spaces. And then the second, we need to filter out the empty lines. So if we want to, we already know that our RDD contains multiple lines, each one of them of type string. So we could do, instead of a map, we would do a flat map. And why we would do a flat map is because we're interested on each word individually. And then we're passing the Python function, or we're calling the method split on each one of those strings. So this is just Python code. And then if we want to count how many of those words there would be, we would call the count action. All right, and then the next part is to remove the empty elements. So how do you go about it? Is there are a few ways of doing it. So I'm just gonna. So you would call the filter function. So one way would be to do the following, to call a filter, and then we would filter those cases where X is different than empty, and that would remove the spaces. Another way of doing it is to actually count the number of elements of each string. So then we would filter and only allow those for which the length of the string is greater than 0. So those two approaches are equivalent. That's to say that in general, when it comes to solving this sort of problems, there are many different ways of doing it. And I think related to the previous question of removing the white spaces before, this is where the numbers would differ. Any questions until here?
Hey, Amanda. Yeah, that's the problem comes when you change the \s to a space. So the number will come here will be different.
Yes.
So what happened? Why caused the difference here? Because you already removed everything else, right?
Yes. I did remove everything else. So then, therefore, yeah, your count would be different. So what is the question now?
I think it's supposed to be same the count, because you only keep the. In this step, by this step, you only keep the letters and digit and space. Everything else was removed.
Yeah, so as we said before, you'll get if you have a space and a new line, the new line is not going to get trimmed by that replace. So you will get a word that's not empty. The word will be new line, the character new line. So that's why you'll have different. You follow what I'm saying?
Oh yeah, I see. So you keep the new line here, so the new line is not empty.
Exactly.
So new line will count as a word.
Yes.
Okay, I see. Thanks.
But I guess you guys are checking here, like if length of string is greater than 0, that will remove that particular empty line, right?
No, that length of strings that has a new line is greater than 0. It's 1 because it's an actual character.
Oh, I see. Okay. Right. So I think I have pasted some regular expression over there. So I think that will help for that particular problem.
Mm-hmm. Yeah. I mean, it's good to review regular expressions. There are plenty of links there where you can learn some more. But yeah, I agree with you. All right. Now that we have counted the number of unique words, let's apply the word count function that we define, and then from that get the top 15 count, or the words with the top 15 counts. So how do we go about it? Well, just for the interest of time, I'm going to copy my solution. So the idea is that you would pass the function, or you would pass the RDD to the function word count, which would return an RDD. And then we will take, in this case, not a regular take, but a take ordered, and we pass the number of elements. And because we're interested in sorting in the reverse order, by the value, we'll pass what will be the sorting key. And that's how you go about it, and then you should get the following count. So one thing to notice here is that you're getting a lot of what is called stop words. So words like the, and, I, to, etc. That when you are analyzing the text, there is some pre-processing step that people often do, and is removing those words because they might not add much to the meaning or to the particular. Of course, it depends on the particular analysis that you're running. So I would not necessarily would say that you always have to remove the stop words, but in most cases, you could continue with your analysis by removing them. The next step is now that we know that there are some stop words.
Armando, is
Yes.
there any way to figure out which are the stop words that we have to remove? Like here we know that there are like certain words that repeat frequently.
Yes.
But is there any like other way, like we have to find like the quartile kind of a things we have to do in that? Or what is
Yeah, so in this case, well, it would depend on the language you're analyzing. So in this case, this is an independent source, or based on the English language, these are a list of stub words. It might not be a complete list, but I think your question is, if you have the corpus only, what can you remove the stub words? So I guess one way to, or why would you remove stub words? It would be words that occur frequently and don't add too much meaning. So doing this sort of thing would be one way. So initially, if you don't have an external data, you would have to examine them, and then from that, maybe remove words that are below a certain frequency.
Mm-hmm. All right, thanks.
So then, as I said, we are copying this particular stub words or this file to the driver. Not advisable. Don't do that ever in production. But in here, we then read that file, and then this SW would be an RDD. So let's see if I run that. Oh, I haven't defined it here. And here. So if we were to examine that stub words, it doesn't exist. Okay. So this is the definition of the stub words. And then to remove it, and I think there were some questions related to this point. Some of the labs coming up will be in a way sort of open-ended like this, and the purpose is that you start thinking on real-time application and put some sort of analysis. I mean, so far everything has been very well guided in the sense that fill in the blanks here, fill in the blanks here, but that's not how things happen in the real world. So the idea here is to start making you think outside the box, in the sense that just look at the results. What happens when I remove the stop words? Is this something that that actually makes sense? Can I infer something from this result?
Is this a part of a second lab, or is this part of a third lab?
No, this is part of the one that is due today, the word count lab. Yeah, it was there.
I think there is some I think there is some sort of a difference because the worksheet that I have doesn't have this part.
That is interesting because I think what we send on the okay, we can look at it offline, but I'm very sure that what we sent contain everything, including this.
The worksheet that I have is up to 4E, like remove empty element. Yeah, up to this part I have.
Okay, that can you send me a message on Slack, and then we follow after because I'm very sure that we send this to everybody. So you might have taken the wrong link.
Maybe, yeah. Okay, thank you.
Okay. So then what do we do with remove words? There are several approaches. One way is to collect that RDD. And what would you collect this RDD? This is small RDD. So might be a good idea to bring that particular small RDD in memory, particular because we are going to be evaluating this RDD very often. And how are we going to be evaluating is because we're going to be comparing each one of the each one of the words that we have with the full list of stop words. So if we have that particular collection already in memory, we would have a big speed up instead of having to read every time from disk.
Armando?
Yes.
Just looking at your code, shouldn't the filter would be the K is not in, not the V? Because the K is the
yes, you're right. You're right. Yeah, thank you for noticing. Yes, of course. Otherwise, we will comparing the value, which would be just a number, and then most likely that would not be there. Thank you for noticing. So if we were to run that. That ran very fast because we haven't actually taken any. We haven't taken any. Any of the values, and this is sorted. No, this is not sorted. So if we want to sort it, we can do take ordered. Which we did here. So let's just copy that, so we don't have to. All right. So this is the result that is expected. I think it was asking for 20. So you would just do that. One thing here is that what do you analyze? So one of the very first thing you see is that somewhat some of the most frequent words are stop words on its own. And that is because the stop words that we use were based on a modern version of English versus the text that we use was Shakespeare. So that would be some sort of insight that you could get at after looking at the results, and that's the sort of comments that we were expecting. So interpret your results, but then of course you might find something interesting that other people did not see, and that would be certainly very interesting. So that was one way of solving the removing stop words. I'm going to show an alternative solution, and this alternative solution, instead of using collect for the stop words, what it does is it broadcasts this particular data set. And remember that what broadcast does is it copies that particular data or that particular data set to each one of the workers. And then why is this useful? Is because this is a small data set, so it's okay to copy that to each one of the workers. And therefore, later on, you can do this comparison much quicker. And then so the results should be identical to what we had before. So this is just an alternative solution. Any questions?
Just a quick comment, why you want to use broadcast. In the first option, if you look at it, what happens is that every task, every step that's going to run that filter will be sent that collection. So if you have an executor that's running 5 partitions, you will transfer that collection 5 times for each partition processing that's running that executor. Even though it's one node, it will transfer it 5 times.
Yes.
Also, it will not, the broadcast transfer is compresses it when it sends it across, so it's more, it's a more speedy way of transferring the data across the nodes. The other thing that you need to remember is when you're using broadcast, or the first option, is that you're going to take memory out of your executors. Because right now, that collection needs to reside in any of your executors. And if you have a large list of words, your executors will not be able to run the task that they need to run. So it will actually slow down your operations. So this is only, this is an acceptable way only if your list is somewhat small. And in this case, so this is, broadcast is best for the use case of you have a large table and you need to join it to a very small list. So that's the use case for broadcast. You can actually, if you're concerned about, because we're running on very small clusters,
right?
You can just use outer join in order to solve this. And that way you're saying, I'm going to make sure that I'm not going to deplete any executor memory for this list.
Absolutely, yes.
Excuse me, I have a question. We could also use reduce by key method, right, to subtract 2 RDDs. So I'm wondering, like, how it works behind the scene and how is the performance compared to the method you just used?
I'm not sure. You want to comment on that? If what happened if you do subtract?
Sure. Excuse me. So what was the question? What did you say?
So I think,
use?
yeah. So this
use
one.
reduce by key to subtract 2 RDDs, right? But I have no idea about
the reduce by key. Reduce by key is just a group by plus sum. It's not.
Sorry. I meant subtract by key.
Okay. So yeah, you can use subtract by key, but it will be actually it will be the same as using a join, because that's what it does.
The same as the join?
Yeah. Subtract by key is basically left join and filter the nulls. Yeah, filter only to keep the nulls.
Oh, okay. So it doesn't bring them into the memory. It is still.
It does a join.
Okay.
And in order to figure out which one is in both.
Oh, okay. I see.
And then it says, if you find it, I just remove it.
Oh, okay. I see. Thank you.
Okay, thank you very much, y'all. I think that was very useful. In the Zoom group chat, I put the link for the attendance. All you have to do is enter your email address in there. So that's how we will count the attendance for today's session. Any questions before we wrap up?
Hi. I've got a question.
Yes.
So for the last exercise, I didn't know like you guys were expecting us to give you guys an insight.
Mm-hmm. Yeah.
So like, is there any way we can change our submission now? I've already submitted my.
Sure. You can just submit another one, and I will take the latest one.
Okay. Thank you so much.
But yeah, in general, yeah. So especially when it comes to this open-ended questions, the idea is that you would they will come more often for future labs. So the idea is that you would start looking at the data, maybe start doing some inference of what the results are, not only just following the steps mechanically. Yeah.
Okay.
Thank you.
Thank you.
So somebody's asking how is the attendance being recorded. I put a link on the on the chat, and that's how it would be recorded. I will just put it again. So please, if you want to get the points for today's attendance, just put your email address in that form. All right, guys. Well, thank you very much. We will release the material for next week tomorrow night, and then with that would be the material, and then the lab, and then also the assignment of grading to other people's exercise. I will also send the solution version, so you have a point of reference, and then we can go from there. So remember, again, if you have any questions, go to the Google groups. During the workday, it might be tricky for me to respond, so I might not be responsive right away. But one thing that we are very happy is that other participants are helping each other, and that is very useful. And then what we like the Google groups is that it will become searchable, and more importantly, it will be organized by topics. So if you have questions, do them there, or the Slack channel as well. All right, everyone, have a good night, and we'll see each other next week. Next week will be again a virtual session. All right, bye-bye. And thank you, Eyal, very much for your help. Very insightful tips to all of us. It's clear that you know the in and outs of RDDs and data frames. Thank you.
Thanks, Armando. It's always a pleasure.
Okay. All right. Bye-bye.